Today's lesson is on scientific notation. And what scientific notation is it's a short form for very long numbers. Again, it's a short form for very long numbers. And what I mean by that is that if you look on this website, it has a lot of crazy real-life examples like the population of the world, the speed of light, the distance from Earth to the sun. And it takes these numbers here in this column, and instead of integer, I would call this standard notation. And it takes things like the cells in a human body, which is 100 trillion cells, and rewrites it as 1.0 times 10 to the 14. Or it takes a really small number, like the mass of a dust particle, which is 753 trillionths of a kilogram, and rewrites it as 7.53 times 10 to the negative 10th. So if you look at this, you've got these really huge numbers and these really tiny numbers, and we rewrite them in what we call scientific notation. If you notice, the first column here, the first factor, 6.17, 3, 9.3, 2.4, 6.0. That number is between 1 and 10. And then you have a factor of 10, 10 to the 8th, 10 to the 7th, 10 to the 5th, 10 to the 12th, 10 to the negative 3rd. Skip down, 10 to the negative 10th, 10 to the negative 3rd. And we rewrite it in a different way. So if I were to go back here, here's a few more examples. What I would say is nice if you want to compare for instance, the mass of the sun in kilograms compared to the approximate number of stars in the universe. If you just looked at this number, it'd be really hard to tell. But when you see 1 times 10 to the 30th or 1 times 10 to the 23rd, it makes it much easier to compare those numbers, and it's in a more concise format. So again, scientific notation, the whole purpose of it is it's the short form for very long numbers. So how is scientific notation written? And I mentioned this just a second ago. But there are two key things that happen. Is the first factor must be greater than or equal to 1 and less than 10, and the second factor is a power of 10. Again, if we go back to what I showed you at the very beginning, if you look at all these numbers written in scientific notation, the first factor is between 1 and 10, it's 3, 9.3, 2.4. They're all greater than or equal to 1 and less than 10, and then you see times 10 to the 8th, times 10 to the 7th, times 10 to the 5th. Now, the second thing that's important to note is that when you notice this, that some of those were positive exponents and some of those were negative exponents. And so what I would actually point out right here is this. A positive exponent means that the number, and when I say number here, I'm talking about the number written in standard notation. And when I say standard notation, I'm saying that standard notation or that standard notation, how we typically see numbers. It means that that number is greater than or equal to 1. Negative exponent means that the number in standard notation is between 0 and 1. So what I mean by that is if you go back here, let's say this, 240,000, it's got a positive exponent, which means it's greater than 1. This one has a negative exponent, which means this is between 0 and 1. Take this one, negative exponent, that's between 0 and 1. Positive exponent, greater than 1. There you go. So, and what you also want to see here is if we had a number line, okay, we would say right in here would be where we would find our negative exponents, and then all throughout here and going forward is where we would see our positive exponents. So again, negative exponents, the numbers between 0 and 1, something like 0.003. Positive exponents would be something like 10,000 is how that would be written out in standard form. So let's go ahead and talk about how we'd actually start writing some of these numbers in scientific notation. And what we do is we take something like 7,500 and we would say the decimal place is here. Well, I want to move it to make it between 1 and 10. So I move it here and I'm left with 750. I move it here, I'm at 75. I move here, I'm at 7.5. So then I say 7.5 times 10, 1, 2, 3. I moved it 3 times. Again, it's not necessarily the number of zeros there are, but it's the number of spaces I move. 1, 2, 3. Let's take a look at number 2. 4,200,000. Let's take the decimal to make it a number between 1 and 10. 1, 2, 3, 4, 5, and 6. That makes it 4.2 times 10 to the 1, 2, 3, 4, 5, 6. And there we have it. So if you look at number 3, we would move the decimal to right here, which would be 6.45 times 10, and we'd count 1, 2, 3, 4, 5, 6, 7 spaces. Okay? Now, what do you write right here is you write every number until you're left with zeros. Once all you have left is zeros, then you stop. But if we had something like this, 102,000, we would say 1.02 times 10 to the fifth, because I'm going to move it 1, 2, 3, 4, 5 spaces to get this between 1 and 10, and so it's times 10 to the fifth. And if you actually work this out, for instance, this, when you say times 10 to the third, 10 to the third is 1,000. And so if you had 7.5 times 1,000, that actually gives you your number in standard notation. So this is not, it's not magical what we're doing here. Again, we're just taking a number and writing it in a shorter form right there. All right, let's write these in scientific notation. Well, these numbers in standard notation are less than 1, so that we know we're going to have negative exponents. So we'll start here. We'll go 1, 2, 3, 4. To get it between 1 and 10, 8.4 times 10 to the negative fourth, because that's a number between, because this is less or between 0 and 1. Take the decimal here. We go 1, 2, 3. That's going to give me 5.87 times 10 to the negative third. Again, you can count 3 spots. And again, it's negative because this number is between 0 and 1. And finally, let's take this number and write it in scientific notation. 1, 2, 3, 4, 5, 6, 7, 8. 6 times 10 to the negative 8. Some people will ask you to write it as 6.0 times 10 to the negative 8. Either way is fine for my purposes. If moving this seems kind of tedious, then just count 1, 2, 3, 4, 5, 6, 7, 8, and there you have it. Now that was changing numbers in standard to scientific. Let's take numbers in scientific and write them in standard form. Well, 7.5 times 10 to the fourth. Because this is positive, we know that this number is going to be greater than 1, so we're going to move to the right. So we take 7.5, we move the decimal 4 places, 1, 2, 3, 4. We fill in the blanks with zeros, and we're left with 75,000. Again, notice that we're going to move it 4 spots. If you move it once, the 5 takes up one of those spots, and then you're left with 3 more zeros, 75,000. 5.41 times 10 to the fifth. 5 is positive, which means this number is going to be greater than 1. So I take 5.41, I move it 5 spaces, 1, 2, 3, 4, 5. The empty spaces I fill with the zeros, and I have 541,000. Again, another way to think about that is I'm going to move it 5 spaces. 2 spaces are taken up by the numbers, and then I have 3 zeros left. Number 3 is 4.7 times 10 to the negative 7th. Okay, that negative number means this number is going to be between 0 and 1. So we're going to slide to the left. 1, 2, 3, 4, 5, 6, 7. And we're going to fill that with 1, 2, 3, 4, 5, 6 zeros because the 4 takes up 1 spot. 2, 3, 4, 5, 6. Add the 7. You can choose to keep this 0 here. It's optional. It does not matter. But these 6 zeros are the ones that are really important. 5.74 times 10 to the negative third. One more example. Move it 3 spaces to the left. 1, 2, 3. Which means I'm going to add those 2 zeros right there. That's scientific notation in a nutshell. If you want to take it to the next level, we could look at numbers that are written. Actually, I'm going to do one more example. Okay. What if you had something like 75.2? You think it may be in scientific notation because you see the decimal, but is this a number between 1 and 10? No. So we have to move it to the left. 7.52 times 10 to the what? First. And as you know, we want to keep everything in simplest form, so I'm going to leave it at 7.52 times 10 to the, or just times 10. I'm going to drop the 1. However, if it was 0.752 and I just slide it over once, that would be 7.52 times 10 to the negative first. And we would want to keep the negative 1 there because we need to know what that negative is. Whereas when it's just a 1, we can leave it off. Last couple examples I want to show you is if you have a number like this, you may think it's in scientific notation because you see the 10 to the 7th. But if you look closer, this number is not between 1 and 10. So what you're going to have to do is slide this over once, which will give you 5.87 times 10 to the negative first. Again, you almost ignore this 10 to the 7th for a minute, and you say, okay, I'm going to slide this over once. 5.87 times 10 to the negative first would be this right here. Then let's bring this back down, times 10 to the 7th. Now I'm going to pause and see if you remember the product rule when talking about exponents. When you have numbers or variables with the same base and you're multiplying, you simply add the exponents. Do we remember that lesson? Okay, if you had c to the 4th times c to the 10th, you would say 4 plus 10 is c 14. We're multiplying numbers with the same base, or exponents with the same base. So we go times 10, negative 1 plus 7 is 6. The other way I like to think about it is you're taking this small number, 0.587, and you're making it bigger by 1, so we have to reduce that by 1 to make it 6. Again, you're taking 5.87, you're making it bigger here, so then that's going to have to become smaller and make that a 6. Look at number 2. This will be our last example. Looks like it could be in scientific notation, but this first factor is not between 1 and 10. So let's make it between 1 and 10. We'll ignore this on the side. We'll go 1, 2, 4.323 times 10 to the second. It's positive because that's greater than 0, or greater than 1. Then we can drop this back down and say times 10 to the 8th, 4.323 times 10 to the 10th, because we simply add the 2 and the 8. The other way to think about it is we're going to make this big number smaller, so you have to compensate for it by adding 2 to that one. We take 2 away, and we add 2. Do nothing very quickly. If I move this 2 to the left, 5.152 times 10 squared times 10 to the negative 4th, we'll add 2 plus negative 4 will give me 5.12 times 10 to the negative second. We're making this a little bit smaller by 2, so we're going to make this bigger by 2, negative 2. Hope you have a great day. Thanks for listening to this lesson.